Hello everyone, this is Dr P Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about F distribution. So, test of hypothesis for small samples. So, already we have discussed in the previous sessions. Once again, we have to recapitulate these slide. So, test of hypothesis for small samples. So, in the test of hypothesis for small samples, we have three tests. First one is the T distribution, second one is F distribution, and third one is chi-square distribution. In T distribution, we have two types of tests are there. So, first one is T test for single mean, and second one is the T test for difference of means. So, now we will discuss about F distribution. Okay, so before going to start F distribution, so what is the meaning of small sample? So if n is less than 30, then we can say that is small sample. Okay, so in the sample, we have sample size is denoted with n, and the sample mean is denoted with x bar, and the sample variance is denoted with s square, and the sample standard deviation is denoted with S. Okay, so now coming to the our distribution, that is F distribution. So F distribution, to test whether there is any significance difference between two sample variances. So that is S1 square and S2 square. We use F test. In F test, the test statistic F is given by F equal to S1 square by S2 square, where S1 square is greater than S2 square, or F equal to S2 square by S1 square, where S2 square is greater than S1 square. So, which is highest value, we can keep it in the numerator. Okay, so here S1 square equal to 1 by N1 minus 1 summation Xi minus X1 bar whole square, and S2 equal to 1 by N2 minus 1 summation Xi minus X2 bar whole square. So this is the formula for F distribution. So observe, same values are there in T distribution for difference of means. So T distribution for difference of means. So if there also N1, N2 is there, X1, X2 is there, and S1, S2 is there, or S1 square, S2 square are there, right? So, and in F distribution also we have same values. Then which method we have to use? Okay, so that is based on the question. So in the question they will give directly the sample is if there is any significance difference between two sample variances, for two sample variances we have to use F test. So if there is any significance difference between two sample means, so we have to use T test for difference of means. Okay. Problems. First problem. In one sample of 8 observations, the sum of squares of deviations of the sample values from the sample mean was 84.4. And another sample of 10 observations, it was 102.6. Test whether there is any significance difference between two sample variances at 5% level of significance. So before start this problem, first of all we need to discuss about some points. So here in F distribution we have to take F alpha at nu 1 equal to n1 minus 1 comma nu 2 equal to n2 minus 1 degrees of freedom. And also if the conclusion is we have 5 methods. No, in that the last step conclusion is mod F is less than F alpha, we accept H naught. If mod F greater than F alpha, we reject our null hypothesis. Okay, so problems. First problem, in a one sample of 8 observations, the sum of squares of deviations of the sample values of the sample mean was 84.4, and another sample of 10 observations it was 102.6. That means here they have given that sample size is 8. Okay, that means what is the how to denote sample size? We know that we have to denote sample size with n, but here we have two samples, right? So that's why here we need to take n1 equal to 8, and the continuation is the sum of squares of deviations of the sample values of the sample mean was 84.4. So that meaning is sum of squares of deviations from the mean is this one. Okay, so here we have two samples now. So sum of squares of deviations from the means, first mean is 84.4. Okay, so like that we have sum of squares of deviations from the second mean, that is 102.6. So here we have a second one, and the sample size, second sample size is n2 equal to 10. So here we are going to find there is any significance difference between these two sample variances. So that is important. Two sample variances at 5% level of significance. So here they have given that alpha equal to alpha value is 5% level of significance. That means alpha equal to 0.05. Okay, so here n1 is, they have given that n1 equal to 8, n2 equal to 10, and the sum of squares of deviations from the means is 84.4, and the sum of squares of deviations from the means, one more mean is there, no? So for that is 102.6. Okay, so now we need, which formula we have to use? We have to use either f equal to s1 square by s2 square. So that is based on s1 square is greater than s2 square. So which is greater value, we have to write that in the numerator. So otherwise we can use s2 square by s1 square if s2 square is greater than s1 square. So we have to use this method. So this is for sample variances. Okay, so now we have to follow the procedure. Before that we need to find s1 square and s2 square. So what is s1 square? We know that s1 square is n1, s1 square is equal to 1 by n1 minus 1 summation xi minus x1 bar whole square. So 1 by n1, so that is n1 is 8, n1 is 8 minus 1 into summation xi minus x1 bar whole square is 84.4. So this is 84.4. So after solving this one, we will get s1 square equal to 12.057. Okay, so like that we need to calculate s2 square. So that is so 1 by n2 minus 1 summation xi minus x2 bar whole square. So 1 by n2 value. So what is n2 value? Here n2 equal to 10. n2 equal to 10 minus 1 into summation xi minus x2 bar whole square. So that is 102.6. So that is equal to 11.4. Okay, so now we need to find the f value. Okay, so we need to find the formula f value. So how to find this f value? We have to use our procedure. So what is our procedure? We need to set up the null hypothesis, then alternative hypothesis, then level of significance, then test statistics. Here we need to write the formula and conclusion. So in the conclusion, mod f is less than f alpha, we accept the null hypothesis. That means we accept our given statement. So if modulus of f greater than f alpha, we reject the statement, or we reject null hypothesis. Okay, so first coming to the first step, that is our null hypothesis, we denote with h naught. So here I am taking s1 square equal to s2 square. So that means there is, here I am taking there is, because in the question they have mentioned clearly. So test whether there is any significance difference between the sample variances. So that's why here I am taking in the null hypothesis, there is no significance difference between sample variances. So we know that sample variance is denoted with s1 square and s2 square. So that's why s1 square equal to s2 square here I am taking. That is the meaning of this one is there is no significance difference between sample variances. So next one is alternative hypothesis. So that is denoted with H1. So here that is nothing but S1 square not equal to S2 square. So that means there is a difference. There is a significance difference between the sample variances. Okay, there is a significance difference between the sample variances. So that is S1 square not equal to S2 square. So simply we can say that alternative hypothesis is opposite to the null hypothesis. So remember this one point here, these two are assumptions only. Null hypothesis and alternative hypothesis both are assumptions. So next, coming to our third step, level of significance. So here they have given that alpha value is 5%. That means alpha equal to 0.05. So now we need to calculate f alpha at nu one equal to n1 minus 1 comma nu2 equal to n2 minus 1 degrees of freedom. So f alpha means f of 0.05 at nu1 is what is the value of nu1? Nu1 is 8. Sorry, n1 value is 8. So 8 10 no. So this is 8 minus 1 and nu2 equal to 10 minus 1 degrees of freedom. So f 0.05 at nu1 equal to 7 comma nu2 equal to 9 degrees of freedom. So we have to take this value from the table. So how to take this value from the table, I will show you. So this is our F distribution table. So in that we have F 0.05 and at nu1 comma nu2 degrees of freedom. So that means these are all nu1 values and these are all nu2 values. In nu1 we have to choose 7. So this is our 7 column and here we have to choose nu2 value. Nu2 value is here 9. So we have to choose 9th row. So 9th row, 7th column, that is 3.29. See here, 3.29. So this value is 3.29. So like that we have to choose the values from the table. We have to take the values from the table. So F 0.05 at nu1 equal to 7, nu2 equal to 9 degrees of freedom is 3.29. So F alpha value is 3.29. So now we need to find test statistics. Here we need to write the formula. So here F equal to S1 square by S2 square. So why we are writing S1 square by S2 square? Always S1 square is greater than S2 square. So we know that S1 square is a bigger value than S2 square. Okay, so that is 12.09 is a bigger value than 11.4. So that's why we have to write S1 square in the numerator. So S1 square is 12.057 divided by S2 square is 11.4. So after simplification we will get F equal to 1.057. So after that we need to write mod F, that is 1.057. So if mod F is less than F alpha, so we accept the null hypothesis. That means if mod F equal to 1.057 and F alpha value is, what is F alpha value? That is 3.29. So 1.057 is less than 3.29. So that means mod F is less than F alpha. So calculated value is less than tabulated value. So if calculated value is less than tabulated value, then we accept the null hypothesis. So that means if F is less than, mod F is less than F alpha, we accept the null hypothesis. That means our statement is correct statement. So what is our statement? So here we have taken in the null hypothesis, there is no significance difference between sample means. So that is correct statement. Okay. So next, coming to the next problem, time taken by workers in performing a job by method 1 and method 2 is given below. So here method 1 values are 20, 16, 17, 23, 22, 26 and method 2 values are 27, 33, 42, 35, 32, 34, 38. So here we have the question. So that is based on the variances. So next, does the Does the data shows that variances of time distribution from the population which these samples are drawn do not differ significantly. Do not differ significantly. Okay. So solution. So here they have given that n values. Okay. So here they have given that n values, and here in the first method n value is sample size is 1, 2, 3, 4, 5, 6. N1 equal to 6, and here 1, 2, 3, 4, 5, 6, 7. Here N2 equal to 7. No, 7. N2 equal to 7. So, but the question is based on variances. That means here we have to use F test. So that means what is the formula for this? S1 square by S2 square, where S1 square is greater than S2 square, or we can use F equal to S2 square by S1 square. S2 square is greater than S1 square. Okay. So we have to use this method. So, but how to find S1 square and S2 square? So here we have only N1 and N2, some table is there. So, but we need to find X1 bar. So, X1 bar means, so because in our question, in our formula, S1 square equal to 1 by N1 minus 1 summation Xi minus X bar whole square. That means X1 bar whole square. Like that for S2, 1 by N2 minus 1 summation Xi minus X2 bar whole square is there. So first of all, we need to find X1 bar and X2 bar. So X1 bar is average of these values. That means 20 plus 16 plus 27 plus 23 plus 22 plus 26 divided by 6. So that is X1 bar equal to 22.33. So like that X2 bar equal to average of these values. Average of method 2 values. That means 27 plus 33 plus 42 plus 35 plus 32 plus 34 plus 38 divided by 7. So that is equal to 34.43. Okay. So X1 bar is 22.33 and X2 bar is 34.43. Okay. So substitute all these values in the formula. So before that, what is the formula here? So S1 square equal to 1 by N1 minus 1 summation Xi minus X1 bar whole square. So we know that X1 bar is 22.33 and X2 bar is 34.43. Okay. So and X1 values are here. So these are Xi values for S1 square. These are Xi values for method 2. S2 square. Okay. So for that substitute all these values here. So 1 by N1 value is 6 minus 1. So summation Xi minus X1 bar whole square. So these are all Xi values 20, 16, 27, 23, 22, 26. So that's why we need to write 20 minus. So this 20 minus X1 bar. X1 bar is 22.33. So 20 minus 22.33 whole square plus 16 minus 22.33 whole square plus 27 minus 22.33 whole square plus 22 minus 22.33 whole square plus 26 minus 22.33 whole square. So substitute all these values in the formula. After calculation, we will get a S1 square. So that value is 16.266. Okay. So next S2 square. So S2 square formula is 1 by N2 minus 1 summation I equal to 1 to N Xi minus X2 bar whole square. So that is equal to 1 by N2. N2 is 7. 7 minus 1 into what is X2 bar? X2 bar is 34.432. So what about the Xi values? Xi values are here 27, 33, 30, 42, 35, 32, 34, 38. So here we need to take 27 minus 34.43 whole square. 27 minus 34.43 whole square. So like that 33 minus 34.43 whole square. 33 minus 34.43 whole square. So like that plus 42 minus 34.43 whole square. 35 minus 34.43 whole square plus 32 minus 34.43 whole square plus 34 minus 34.43 whole square plus 38 minus 38 minus 34.43 whole square. So after simplification, we will get s2 square equal to 22.285. So which is bigger value? s2 square is bigger value. So that's why we need to write in the numerator, because our formula is s2 square by s1 square, where s2 square greater than s1 square. Okay, so first of all we need to write 22.285 in the numerator, because that is bigger value than s1 square. So now we have a procedure to find this problem. So first one is null hypothesis. So null hypothesis is nothing but h naught. Okay, so in the h naught, here I am taking s1 square equal to s2 square. That means there is no significance difference between variances. So next we need to write the alternative hypothesis, that is denoted with h1. So what is the alternative hypothesis? Opposite to the null hypothesis. That means here I am taking s1 square not equal to s2 square. That means there is a difference between the sample variances, or there is a significance difference between the sample variances. So that means that is s1 square not equal to s2 square. So next we need to take level of significance. So here they have not mentioned alpha value. That's why we are assuming that alpha equal to 5% or alpha equal to 0.05. So now we need to calculate f alpha at nu1 comma nu2 degrees of freedom. Nu1 comma nu2 degrees of freedom. That means nu1 is nothing but f alpha at n1 minus 1 comma n2 minus 1 degrees of freedom. So that is f alpha value is 0.05 at nu1 is 6 minus 1 comma n2 is 7 minus 1 degrees of freedom. Okay, so that means f 0.05 at 5 comma 6 degrees of freedom. So you have to take this value in the F distribution table. Okay, so in the F distribution table that is there in the top, so that is f of 0.05 at nu1 comma nu2 degrees of freedom. So the table is like that. These are all nu1 values and these are all nu2 values. Okay, so we have to take nu1 nu2 values like here. So this is our answer. So that is our value. That value is 4.39. Okay, so f alpha at 5.6 degrees of freedom is 5,6 degrees of freedom is 4.39. So this is our f alpha value. So now we need to calculate test statistic. So our formula is f equal to s2 square by s1 square. Why we are writing this formula? Because s2 square is greater than s1 square. Okay, so that means s2 square value is 22.285 divided by s1 square value is 16.266. So after simplification, we will get f equal to 1.37. So that is mod t. So here we have to take, if it is positive only, we have to convert it to, sorry, if it is negative only, we have to convert into positive. So that's why we have to take mod f value. So mod f equal to 1.37. So here mod f is 1.37. So here mod f is 1.37 and f alpha is 4.39. So 4.39. So 1.37 is less than 4.39, right? So that's why mod f is less than f alpha. So that means the meaning is here the calculated value is less than the tabulated value. So if the calculated value is less than tabulated value, we accept the null hypothesis. That means here f less than f, modulus of f less than f alpha. That means we need to accept the null hypothesis. So what is null hypothesis? There is already we have taken in the null hypothesis. What is that? There is no significance difference between the means. There is no significance. So this is come from the question. Okay, this is came from the question. So there is no significance difference between variances between the variances. Okay, so like that. That means between the variances means our statement is true statement. What we have taken in the question is in the null hypothesis is our statement. So that is a true statement. So we accept that statement. So these are all exercise problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.